the endorsement. I would say for those that aren't familiar with Rocky Mountain Institute, we're an energy think and do tank focused on transitioning our economy off fossil fuels using market-based approaches. So a lot of our work is around thought leadership in terms of new business models that one could adopt in order to scale the adoption and acceleration of renewables and energy efficiency in the marketplace. So today what I'm going to talk about is a more industrialized approach to doing net zero energy retrofits for low-income multifamily buildings. And I'll start out by kind of describing what the name of our program is Realize. So I'm going to describe a little bit about the program. Some of you may have heard of it before, so I apologize if this is repetitive, but I thought it was good to kind of start there. And then we'll talk about a retrofit model that was developed in the Netherlands and kind of the components to that retrofit model. And then we'll talk about a DOE pilot that we have. I didn't end up including, the reason I'm actually in California, I used to live in Colorado, where we were founded, is because we won a California Energy Commission Award to adapt this model that I'm going to talk about from the Netherlands to the California market. But we just started that project. Nehemiah is part of our team. And so we're kind of just getting going. So I don't have that much to share quite yet. Our goal, as I said, is to develop a business model inspired by Energy Strong to catalyze the industry to make net zero energy retrofits readily available, cost effective, and beautiful here in the U.S. residential market. So I'll start by defining the problem. I think it's important to kind of take a step back and talk about energy efficiency and renewable energy as something that we kind of, our industry, I think, has thought of it as like, how do we kind of tack this on to something that's already happening? And I think it's actually kind of been to the detriment of its adoption. So let me just give an example of why it's still complicated and there's so many points of attrition along the way. So when you go to get a cell phone at a Verizon store, if you walked into that store and they asked you to pick out the hardware that was going to go into your cell phone, to pick the towers that you want to run your service through, perhaps the frequency of the signal for that tower, and please come with your financing readily in hand as well, you probably would not have adopted cell phones at the rate that you have seen them adopted, right? Because all of those services are integrated and that brain pain is taken out for you. And so we need to think about renewables and energy efficiency in the same way. They need to be a part of a full set of offerings that get you to a set of outcomes that you desire as a consumer. So in my mind, this is part of the problem. So what is the solution? Let's see if this video will work. How do I click? It's embedded. It is embedded in the PDF, but when I click on it, it just goes to the next slide. See if that works. Right, I might just jump online. This is obviously, okay, here we go. 1 second. I think it's important for people to see it.
Don't open a new tab.
I think it's working, there's just a delay. I'm kind of used to this happening to me every time I try to show this video. There it is. I don't think you'll be able to hear the music. Oh, it's so slow. It's playing, there we go. So, okay, these are some pre-fabricated wall panel systems that are delivered on site. This is a 3D scanning machine that they use as well, where they line up this prefabricated panel system that was based on a 3D scan of the existing geometry of the building to perfectly place it onto the wall. All those window and door openings that you saw in there, again, 3D scan informed where those were cut in the factory based on the existing geometry of the building. That thing that you saw hanging in the air was a pre-integrated mechanical pod, that white box. So it's got their heat pumps for domestic hot water, heating, some degree of cooling and ventilation, and then a PV inverter as well. So all of that is attached to the exterior and integrated into their existing hydronic heating system. You can kind of see him tinkering around in there. Sorry, this is so jerky. And then they just kind of finish out the windows. They're nice, deep windows. These are designed to perform at passive house levels. And let's see, I think it's almost done. Okay, yes, and then they come and they take the terracotta off because it's very heavy, and so it allows for the roof to be able to support this new insulated roof system that has a pre-installed solar racking system. Let's see what else. And this is a retrofit that was done in one day. Some of the pre-site work includes kind of doing some trenching around the base of the building, so the panels do go below grade, about a foot or so. And some of these units have, you know, like chimney stacks and all that. All of those are removed. All those, what's the exact technical term, where you're breaking the thermal envelope. Anyway, they remove those breaks in the thermal envelope. And sorry, this you can YouTube this, just Energy Sprong. But I thought it was important for people to kind of see how it's kind of like a kit of parts, kind of like Legos. And this this approach has been, as I said, used in the Netherlands on thousands of units, and it is scaling to Italy, Germany, France, the UK. The UK has successfully completed a project. Retrofit New York now exists here in the United States and is adapting the Energy Sprung model. And then RMI is hoping to support, again, bringing it to California, but scaling it nationally as well. So I'm not quite sure. I think it's just, there's just a lag. So to get this back into full screen, do I just... Full screen mode? Okay. Okay, there's just a little bit of a lag. Okay. So thanks for indulging me on that. So something that's really cool about what they've done. So while there's a technical component to the model, there's this whole, like I said, full service offering that comes with it. So, you know, these are high quality, like I said, passive house level performance, but these also include long-term performance guarantees. And they've created a really new and interesting model for how that works. The contractor is the entity that holds the performance guarantee. It's not an energy service company that holds the performance guarantee. They are given a maintenance fee annually, and they just maintain these systems. And then the way that the mechanical systems predominantly are instrumented is such that you can differentiate between behavioral issues and performance, and you know, like infrastructure issues with performance, so that again, that contractor can come out and maintain those systems to achieve that performance. So another core tenet of the design was for these to be done quickly and to be non-intrusive, so that tenants are not displaced. So those tenants remain in place. I'll show you some pictures of that. The idea, similar to what the last gentleman who spoke about, is that this is financeable using the utility bill savings. And that economic model that you showed is exactly how these projects work. The idea is that that additional amount of debt that you're able to leverage is what pays for that incremental cost at a major rehab to go deeper in the building. And then again, at the end of that video, I think you saw that the building looks beautiful. I think, yesterday we were talking about, social movements and how do you talk about this with your peers and feel proud about it? And we've got to move beyond getting excited about talking about the heat pump and get excited to tell the story about, look, this is what my whole, it's practically a new house. So that contagion aspect was really important. Okay, so here's just an example of some of the, projects out there. This is a 4-story, I guess 5-story building when you include this basement looking area that they've retrofit. As you can see, they have enclosed the balconies. Those are little thermal bridges that are basically used for holding a lot of stuff. People don't generally even, kind of hang out on them. So it's like they're still using that space. Let's make it conditioned space and remove the thermal bridges. Here are some other examples of the different facade styles. So again, even though this is standardized and industrialized, you have a lot of variety in terms of aesthetics. And I think some of them look pretty cool. Like this one with wood on the right, I think and just tons of glazing, which is kind of surprising. That is brick veneer on the left. And I'll show you some other pictures, I think, of you can pick your different styles of brick veneer, and there's a robot at this one factory that sticks on little brick veneer pieces. And then on the bottom right, you can kind of see those, the energy pod kind of in behind that grass, but I'll show you more of the pods later. But some of them are installed internally and some of them are installed externally. So we got to visit a company called RC Panels, and this is a picture of their production floor. These are very simple. Obviously, these are low-rise buildings that I'm showing you, but one thing to mention is that the first thing they did, the way this whole thing started was the Dutch government gave an award of $40 million, right, to figure out what are we going to do with existing buildings in the Netherlands to get them to zero, to meet our climate goals. And they screwed around for, 3 or 4 years. It was like a 5-year grant. And like in the 4th year, they were like, this is what we're going to do. They finally figured it out. And so basically, what they did, though, was they realized they had to look at the building stock and put it into typologies. So that's the first step, is like, what are the main typologies of buildings so that you can develop a solution for that typology that can be repeated over and over again. That's the first thing we'll do in our California project. We look, so when I call everybody and ask you about your typology study, that's why, right? We're trying to get as much information as we can to figure out enough about the building geometry and the construction type specifically. That's really important as well. So that we have these different classes of buildings that can have very similar envelope. Some of them in California might not need anything done to the envelope, but others might, depending on climate zone, again, so we can put them in those buckets. So they did that in the Netherlands. So they started out with these low-rise terrace-style buildings that were just the worst performers. And so they can put these pretty basic, it's a graphite-infused EPS foam in the center of these. They have a fiberglass backing. They have this like vacuum sealing gluing process that attaches it to the fiberglass. They put OSB on the top. They use the CNC machine to cut out the windows and the doors. Again, they did a 3D laser scan to get the exact geometry of that building. That's what feeds into the CNC machine that cuts out the exact location of the windows and the doors. And then they have the robotic arm that can stick on these different styles of brick veneer.
What's the bar rating of it?
I guess I don't know what it is in the Netherlands, but I'm assuming it would be comparable to like what our low-rise fire ratings are. And like, I don't think this is that different than it's a SIP panel. So, sorry, I don't have that answer yet. So this next picture is just to give you a sense of kind of like how so that's a panel manufacturer, and the panel manufacturer is a supplier to a contractor. But some contractors are deciding to vertically integrate, and they're producing their own panel systems, and they're taking this all the way to, you know, full production homes, modular homes. So we went, and we weren't able to really take very many pictures, but this is the showroom of a company called BAM. It was like a big unveiling of their showroom. And it's like walking through an IKEA, but you're like walking in and picking a whole building. So they have these different buildings. You walk in, you get to walk through. Then like you can see a little bit on the bottom right, like there's different toilets you can pick out. They have all the fixtures, all, you know, all of the tiles, all that stuff, so that a client can come through and basically pick what their home is going to look like. So this is it's a construction company that has chosen to do this. The Netherlands. And so BAM is vertically integrated, and not only producing their own panels, but also the general contractor for some of these retrofit projects. But they were very disciplined in saying we have to be able to do both new build and retrofits, and in designing their production floors to be able to do both. So this is just an example from an install. In the top left-hand image, you can see these galvanized steel racks that are what the panel systems hang on. And then on the right-hand side, you can see there's a tenant literally talking to us through his open window as he gets ready for them to hang a wall panel that day. So they really are keeping tenants in place. Some tenants, if the tenant's really adamant, I want to get out of here, that, you know, they'll move the tenant, but for the most part, they stay in place. You can see a little bit of these yellow dots on the right-hand side. Those are marks for where that energy module will plug in, and where the refrigerant lines and any sort of plumbing lines will go through there. And yeah, and then this is the guys just kind of, I guess, preparing for framing the window. And then I think on the left, you can see a little bit of trenching, like I said, so that those panels can go slightly below grade. So this is just taking that one project that I showed you. These are all electric retrofits. They have a mandate to be off natural gas in the Netherlands by 2050. Yep, they don't want to buy any more Russian, I guess, natural gas. So this is a tenant who's just loving her kitchen. I mean, you know, I also think people are emotionally attached to gas because they haven't experienced induction, but you can have a really sleek looking kitchen. And then they really like the depth of the windows. They can put plants on there, and it just creates. I personally, so I lived in the Southwest, and I love adobe buildings, and I feel like when I'm in a building that has thick walls, I feel like I'm in a higher quality building. So it does create a feeling of quality to have those thick window depths. Okay, mechanical systems. As I mentioned, they're all electric. These pods are including a heat pump for both domestic hot water and space heating. Some of them have a little bit of cooling capacity. They hook into the existing radiators. They also have an ERV, although they don't have, I think, the same kind of level of humidity that we have in the Northeast and the Midwest, and obviously the Southeast. There's a solar panel inverter in there, and then they have like this like control board that helps the systems communicate amongst each other, and then also allows for the instrumentation that's communicating with a company that does all the data analysis to see if the systems are properly performing in order to support that maintenance work that we were talking about. In the case, the projects we got to go to, some of them had centralized systems, but the model was really moving more towards this distributed approach to the mechanical systems. On the mechanical system side, so one of the cool things that Energy Sprong did, just to be clear, Energy Sprong is a market facilitator. They're not a company. They're not a producer of the panels. So what they have tried to do is remove market barriers and facilitate these kind of preliminary deals to get the market to produce this type of offering. So they negotiated a contract for 11,000 units of retrofit demand with the 6 largest affordable housing, social housing owners in the Netherlands. And that was enough demand to start 3 companies up with producing panels for these projects. So 3 companies started doing this. And now there are many more. They did not have the same success on the mechanical system side, and we have also experienced something similar. There's a lot more complexity on the mechanical system side of bringing all these components together, and getting an incumbent to really put some resources into R&D and stand behind the product. One of the founders of Energy Sprong actually founded a company called Factory Zero that is making these mechanical pods. And this is what the inside of them look like. This is just kind of showing you what's in that thing. There's, like I said, the PV inverter, the heat pumps, the control board, and then you can see the ERV at the bottom with the manifold, and then the domestic hot water tank, which is quite small. And again, these are for 1 unit. This is just showing you some examples of innies versus, I guess that's a window term, innies versus outies. But the picture on the left are mechanical systems that will be installed on those balconies that they're enclosing. A lot of the time they use that enclosure of the balcony to create a kind of mechanical room. And then on the right, you've got some that are on the exterior. And something to note about the project on the right, they ran their ventilation systems in behind the existing facade and the new wall panel system, and they ran it up over the roof to get to the units on the other side. They're really thin, yeah. And this is just an example of the Factory Zero tenant interface, and kind of just showing what the tenant experience is. You can see, the temperature settings in the home, how much ventilation there is, and that on the top image of the screen on the bottom left, where there's a smiley face, it's kind of showing where they're at for their monthly energy consumption. There's a green face, you're doing great. And then it's kind of showing you the different loads on the bottom, how much solar you're producing, and how you're doing kind of relative to your budget for those different loads. This is showing you this performance kind of guarantee and the structure of relationships in order to navigate that. So you have performance warranties, like a warranty on the panel system and a warranty on the mechanical systems, and those are held by your suppliers, right? Your solar panel provider, your roof system, your wall panel system, and your energy pod. There's a warranty. But then there's, like I said, this performance contract, which is a contract between what they call the solution provider, which is the general contractor, and the owner, and then the tenant. So these are tenant metered properties. They're not master metered. So the tenant has a contract with the owner. They're given an energy budget, and they basically are guaranteed a certain plug load, a certain amount of domestic hot water, a certain temperature band within their building at different times of the year. Even the amount of noise that the heat pumps produce is even defined by this energy plan. And if the tenant goes over, because they already have, their unit is connected to the utility, they just receive a utility bill if they overconsume above their budget. But if they stay within their budget, they don't have an energy bill. And so they're basically paying. This is a way to get around another way to get around the utility allowance issue. They are paying a monthly service charge to the owner, who then can underwrite that for the project. And the energy pod provider is the one who does all the monitoring to, as I mentioned, to manage these 2 sets of contracts. Okay, so then I'll just close with our DOE pilot, which was kind of what really, we started out with like a CNCA grant of like, I don't know, like $70,000 to look at the San Francisco Bay Area and if this model would work in the Bay Area. That was our seed funding. And then we we're very fortunate to get a grant from the Department of Energy to test this this kit of parts in a cold or mixed humidity climate. And the DOE is just very skeptical about the building science of this. Like, what happens when moisture gets in between these two, the existing facade and the new facade, right? That's the big building science risk, I think, from most people's perspective. So we've issued 4 RFPs. We issued an RFP for our design and engineering partners, who's Revision and Stengel Engineering, or who we're working with. Then we issued an RFP for a pilot building. We did that typology study in the Northeast and the Midwest. We looked at what the most common multifamily building types that were about 30 units plus. And we identified structural masonry with radiant heating system, central boilers, as a very common building type. So we issued an RFP asking building owners to submit their buildings that were up for a major rehab to put their buildings up to be one of our pilot buildings. So we selected the Eva White building, which is in Boston. There's 2 of them. Right now the plan is that we'll do 1 of them. What's interesting is that the buildings that are white next to it have done a very similar retrofit. It's called Castle Square, and they had Kingspan panels that were put on the building, I think back in 2007. So it's been reskinned, new mechanical. So everyone's kind of like, well, how is this going to be different than Eva White? And the main way is it's the process for how the panels are produced. They're going to be unitized panels, which means the windows and doors will be pre-installed. We were hoping to do individual mechanical systems. It's like a 7-story building. There was a lot of skepticism about having individual units, for every single unit in this building. There just isn't enough floor space. So we're going to do some sort of a hybrid on this one, and we're probably going to use a VRF. The building owner really wants to use a VRF. Everybody's obviously very scared of using heat pumps in cold climates. And the domestic hot water thing is something that also likely is going to remain centralized. So that's the building. And I mentioned, so this is just a little bit about it. So single pane windows, uninsulated concrete, tons of thermal bridging. They've got this big open airway on the bottom with these giant concrete pillars. So we're thinking that we want to enclose that. We'll redo the roof. And then there's not a lot of ceiling height to work with. I think it's at the minimum amount of allowable distance from the floor to the ceiling. I don't know how you say that, ceiling height. So we can't really run a lot of extra ducting and stuff. And these are ventilated where there's air coming into the hallways, and then the air is being sucked in under the doors. That's how they're ventilating the units. So that's one of the biggest complaints is like, I can smell everything my neighbor's doing, and it smells bad. So, like cooking smells and grease. And so the ventilation is, I think, one of the biggest priorities for the building owner. They use PTACs to cool, and they are owned by the tenants. And in the winter, that's obviously just, leaking a ton of cold air in. And then they've got these old boilers that are on this penthouse that's up on the 7th floor. And so those will go. As I mentioned, the ventilation is just being poured into the hallways. And then I think they recently did do an energy service contract and got new domestic hot water gas water heaters, but we're hoping to get rid of those. So that's that. And the last thing I'll say is we issued an RFP for a panel manufacturer, and we selected one, and then they got acquired and then they backed out. So now we're working with another panel manufacturer it's really cool. It's like a concrete alternative material, so it has a much lower embodied carbon. And they're super progressive, and their passive house, it was invented by these two brothers. It's called NRA, and they were just recently acquired by an investor in Vancouver. So we're hoping to work with them. They're called Nexi, but they're very under the radar. So that's who we're hoping to work with as our panel manufacturer. And then we did issue a mechanical system RFP, and we got a couple of responses, but it just wasn't the right set of systems for what we need for the building. So that's been the next thing we have to figure out. What I did want to close with, though, is one of the most important things about getting costs down on this, because right now it just sounds kind of like, you know, a science project, and that's nice, it's futuristic and shiny. But we really need to work with, we've been working with Wind Company. They own the building in Boston, and they're just such an incredibly visionary portfolio holder and owner, or portfolio manager as well. And we have to work with building owners that own large volumes of building stock, so that we can aggregate that demand and look at it again, put it into building typologies, and help them kind of negotiate group procurement for these new innovations, and also that helps build enough of a pipeline for new entrepreneurs to start developing these products if the incumbents aren't going to do it. And so a big part of our work is around engaging building owners on developing a zero overtime plan for their portfolios. And the idea there is we recognize, you know, you're not going to have a major rehab on every single building in your portfolio, you know, right away. How do we start looking at these trigger events and help you plan for them in a way that allows you to take the whole portfolio to zero by a certain date? And so that includes figuring out the financing for each of those different types of buildings. And it's really important for public housing owners that have they're just bleeding money. They need to stabilize their portfolios. And so we're gaining a lot of traction with developers and portfolio owners kind of using this approach and coming up with a plan, even for those emergencies when, you know, your HVAC systems suddenly go out, like having a plan in place and having your internal teams coordinated to be able to act on this without a lot of brain pain. So that's our zero overtime approach to engaging portfolio owners. And this is kind of just an example of a calendar where you see all these different buildings having these different types of events, you know, out over time. So that's what I've got for you guys today.